Sizzling temperatures are great when you're outside grilling or making s'mores over a campfire. But that kind of heat is not usually welcome in a production line. Let me explain. A while ago, a company I work with had some issues with their larger machines heating up a little. Now when I say a little, what I really mean is hot enough to roast marshmallows over. Not good. Production stopped, everyone was anxious, and nobody slept well while the experts searched for the cause. The funny thing is, all that stress and additional cost came down to this: a loose screw. Once it was tightened, the problem went away. Had they known to tighten that screw ahead of time, they would have avoided a lot of lost sleep. This was a catastrophic shutdown, but smaller events happen every day. Even the tiniest of screws can make a big difference down the line, or worse, lead to recalls. We know that these kinds of issues happen all the time, but how do we solve them? Well, one option could be to hire a seer like Nostradamus to predict when things are going to go wrong. Unfortunately, he's quite dead. So we'll have to do something a little different. The good news is there's a solution. It doesn't even require any mysticism, just data, and it's called predictive maintenance. Predictive maintenance is a hot topic, and not just because it keeps your machines from catching fire. It uses data from sensors and other sources to identify problems before they happen. It sounds simple, but actually doing it can get a little complicated. However, when it saves you millions of dollars in downtime and equipment replacement costs, the implementation is definitely worth it. So let's talk about how you can set yourself up for success. Predictive maintenance requires 4 primary things to effectively implement: sensors, connectivity, analytics, and machine learning. Sensors are the backbone of any predictive maintenance solution. Nowadays, there are lots of options to monitor temperature, humidity, vibration, pressure, and more. And it's all done with single chips that can fit on the end of a pencil. To read the data, your sensors have to connect to something that monitors and controls the input. Usually, sensors communicate through a standard protocol like I2C to an onboard processor, like a single board Rio that NI might provide. Next, you'll need some way to transfer the data from the onboard processor to the cloud or an on-premise solution where it will be analyzed by a data analytics application. That's when the insights begin to emerge, especially with machine learning. Once the data arrives in the analytics package, computers can predict and produce valuable information from that raw data, all in a matter of seconds. From the patterns, you'll get essential information, like if your wind turbine is about 2 hours from catastrophic failure, or when it's time to change out a filter on a piece of machinery. This information can be priceless, especially when it says you're 10 days out from roasting marshmallows off your equipment. Effectively implementing predictive maintenance is not as simple as installing new software. Weaving it into your systems can be complex, but the amounts of downtime and money it can potentially save you are enormous. Remember the company that was in a bit of hot water with their loose screw? I'm happy to report they not only fixed that problem, but also implemented a new predictive maintenance solution. Now they can prevent a problem instead of racing to try and fix it, because even something as simple as a screw can cost you thousands of dollars. And it turns out that knowing when and where to tighten that specific screw is a lot easier than rushing to find which one is loose to begin with. Implementing predictive maintenance on your own systems may seem complex or expensive, but it will make you a hero when it prevents small problems, ones that might be fixed by the simple turn of a screwdriver, from becoming disasters. And it'll keep the heat where it belongs, outside.